Here are solutions to perfect problem 7 for Math 65. Given a bunch of stuff to factor. All right, first one, 8x squared minus 6x minus 9. The method we have for these are we want to find, maybe I'll call this step 1. Step 1 is to find two numbers that we want them to add to the middle term, so add to negative 6. But we want them to multiply to whatever the a times c is, to whatever the leading coefficient times the constant term is. We want them to multiply to negative 72. Kind of a big number, so it might help to write things off to the side. 72 is 1 times 72, or it's 2 times 36, or it's 3 times 24. Geez, what else is it? 4 times 18. 5, no. 6, yeah. 6 times 12. 7, no. 8, yeah. 8 times 9. I think that's all of them. So, okay, we want them to multiply to 72, actually negative 72, so we want one of the two numbers in our pair to be negative. We want them to add to negative 6. So I think this is the pair we want to look at here. If we make the 12 negative and the 6 positive, in other words, if we take plus 6 and negative 12, I think we'll get what we need. Step 2, I want you to replace negative 6x with positive 6x minus 12x. In other words, right, this is 8x squared plus 6x minus 12x minus 9. And then step 3 is factoring by grouping. Factor by grouping. Take your first two terms here and look for the greatest common factor. Let's see, they're both even and they both have an x. Pull out a 2x and I'd be left with 4x plus 3. Then take your next two terms and try to pull out something so that you'll be left with 4x plus 3. I think what that something is a negative 3. And then we have two terms and they each have a 4x plus 3 in them. So I can say this whole thing is 4x plus 3 times 2x minus 3. Oh, and check your answers. Man, I made this problem obnoxious. Okay, we can check our answers. Maybe I'll switch colors. Check our answers, multiply that mess back together. 4x plus 3, 2x minus 3. Do this little box method here. 4x times 2x is 8x squared. 2x times 3 is 6x. 4x times negative 3 is negative 12x. Negative 3 times positive 3 is negative 9. We get 8x squared minus 6x minus 9, which sure enough is what we wanted to get if you go all the way back to the start. Whew, all right. All that just to do the first one. Although I think the first one's the worst. The second one, we get x cubed minus 27. The trick for this one is it's a difference of cubes, and we have a formula for difference of cubes. A cubed minus b cubed is equal to a minus b times a squared plus ab minus b squared. Kind of the way you can remember that is these signs are the same, these signs are different, and this sign is always negative. Is that true? No, this sign's always positive. Should be a plus b squared there. Yeah, that looks better. Anyways, this is my formula, so in this case I have my a is x and my b is 3. So what I can say is x cubed minus 27 is the same as x minus 3 times x squared plus 3x plus 9. So this factors to this. We can check our answer. Apparently my checks are in red by doing x squared plus 3x plus 9 times x minus 3. Do the old box method here. X times x squared is x cubed. X times 3x is 3x squared. x times 9 is 9x. Negative 3 times x squared is negative 3x squared. Negative 3 times 3x is negative 9x. And negative 3 times 9 is negative 27. And if you combine like terms, you get x cubed. Those cancel, minus 27. Awesome, we got the right answer. The third one says factor x cubed plus 1. Guess I'm going back to, maybe I'll use a different color. Let's make this one black. X cubed plus 1. This here is a sum of cubes. So kind of like we had above, we're going to have a formula. And the formula for sum of cubes is a plus b cubed is the same as a plus b times a squared minus ab plus b squared. The way you can remember that is just like up here. First two are different. Oh, sorry. These two are the same, just like these two are the same. And then these two are different, just like these two are different. And then this one's always positive. Talking about the signs there. So I can apply this formula with a is equal to x and b is equal to 1 and get that I got x plus 1 times x squared minus 1x plus 1. And then I suppose I should check my answer. X squared minus x plus 1 times x plus 1. If we multiply those back together using our box method, x times x squared is x cubed. X times negative x is negative x squared. X times 1 is x. 1 times x squared is x squared. 1 times negative x is negative x. And 1 times 1 is 1. So what I get if I add, whoa, that's not what I was trying to do. Add these all back together, I get an x cubed. X squared, negative x squared cancel. Negative x, positive x cancel. And I got my plus 1. So sure enough, these did all work out. I got what I was supposed to get. So this factors to this. Finally, there's one more. X to the 4th minus 16. The trick for this one is to notice that you have a difference of squares. So if it's difference of squares, we can write it as x squared minus 4 and x squared plus 4. But then this first one is still a difference of squares. So we can write this as x minus 2 and x plus 2. This one we can't do anything with. So we leave it as x squared plus 4. But this one we could rewrite. And so what we get is that this is the factored form here. And we can check our factored form by first multiplying x minus 2, by multiplying these things back together. I'll do it by first multiplying these two terms back together. Probably don't need the box method for these ones because it's a special form. But if it helps, you can do it. Get x squared minus 2x plus 2x and minus 4. So what you get is x squared minus 4. And so this right here is x squared minus 4. I could then multiply x squared minus 4 with x squared plus 4. Multiply this thing with this thing. And what I get if I make all my boxes, x squared times x squared is x to the 4th. X squared times negative 4 is negative 4x squared. X squared times positive 4 is positive 4x squared. Negative 4 times positive 4 is negative 16. If you add those all together, you get x to the 4th. These two cancel out. Minus 16. Checks out. We're good. Answer's right. That's the end of this perfect problem.